Hello students, let's study the cells in series combination. Let's derive equations to equivalent EMF and equivalent internal resistance of cells in series combination. For convenience, let's consider two non-identical cells in series combination with EMFs E1 and E2 and internal resistances R1 and R2 respectively. Now let's check if whether the cells are in series combination or not. So let's mark the terminals across which cells are connected. So across A and P we have the first cell, across B and C we have the second cell. And it is very obvious that one terminal from both the cells only kept a common connection, which is at B. The other two terminals of both the cells are free to be connected with any other components. So the cells are found one after the other. So we refer to such a combination as a series combination. The combination is a series combination. Now we will draw a figure equivalent to such a figure in which we can see two cells in series combination. So equivalent figure we are drawing. In that we will have a cell, namely equivalent cell, such that the EMF of that cell will be completely equating the net EMF which is expected to get from the above two cells in series combination. And this equivalent cell is with net internal resistance which will be completely equating the net internal resistance of the above two cells in series combination too. And second cell, say the equivalent cell is expected to send out a current which is similar to the one coming out of the above two cells in series combination as well. And you can note that the equivalent cell is between the same two N terminals A and C here. Knowing all this, we will proceed further. We will write for VAC with respect to first figure, which can be so VAB plus VBC, where VAC, VAB and VBC are the potential differences measured across the points AC, AB and BC. Now we'll substitute for the potentials VAB and VBC, say in terms of corresponding cells appeared across those points. So first for VAB, when you write, it is in terms of first cell, and let's know I is the current which each come out of both the cells in series combination. I is the current common to both the cells, say E1 and E2, as they are in series combination. So VAB we are writing as a terminal potential difference as seen a current is drawn out, but in terms of first cell. So VAB can be E1 minus I into R1, and VBC can be say E2 minus I into R2. So we wrote equations to terminal potential differences regarding first cell and second cell in terms of EMF, internal resistance and current. And now group the similar terms and leave this equation as number 1. Now we'll write VAC with respect to the second figure in which equivalent cell is connected. So VAC shall be written as the potential difference between A and C, or the terminal potential difference for the equivalent cell, which shall be E equivalent minus I into R equivalent, say by the theory of cells. So this is number 2. And when you compare equations 1 and 2, it's found the left sides as equal. So now let us compare the right hand sides. So we'll write E equivalent to be E1 plus E2 and R equivalent to be R1 plus R2. So E equivalent is E1 plus E2. R equivalent can be R1 plus R2. So let us conclude that when you have two cells in series combination such that the cells are in order, just like positive negative like that, the sum of what the individual EMFs will be deciding for the equivalent EMF. Okay, if there was one more cell means plus E3 will come. And what's the conclusion now regarding equivalent internal resistance, which will be the mere sum of the individual internal resistances as the cells in series combination. So here you can note that the resistance is combined as in case of what usual resistance is in series combination. So if there was a third cell, then R equivalent could be R1 plus R2 plus R3. Now different cases here, let us see. So first case, in case the second cell in different order. So we shall write E equivalent to be E1 minus E2. R equivalent must be the same, say R1 plus R2 itself. So only the second EMF got a negative for the reason that's found in different order with respect to the first cell EMF. So E equivalent can be E1 minus E2 written. R equivalent won't be found changing. That's the same. And now second case, we'll see. When you have second case, when you have more cells, say 3 cells with parameters E1, E2, E3 and R1, R2, R3. So E equivalent can be E1 plus E2 plus E3, provided every cell is in order. So they keep a order of positive, negative like that. R equivalent can be R1 plus R2 plus R3 here. So now third case we'll see. What if when we have a fourth cell, then plus E4 and plus R4 will come. Now if you have the cells up to n numbers, then E equivalent can be E1 plus E2 plus E3 plus E4 plus up to En. R equivalent shall be R1 plus R2 plus R3 up to Rn. Then fourth case, what if those n numbers of cells are identical with EMF and internal resistance? Then E equivalent can be E plus E plus E plus up to n times. So Ne. So R equivalent can be R plus R up to R n times. So that is Nr. So these are the cases regarding cells in series combination. Thank you.